Hello, good morning and good afternoon also from my side. My name is Václav Švup, and I can drive this breakout session, which will focus on the flexible manufacturing for parts production. I hope you enjoyed so far the first, let's say, part of our automotive summit. And I'm pretty sure that you will enjoy also the second part, which are dedicated breakout sessions, deep diving into the specific topic. So hello again, and let's begin. Maybe at the beginning, one administrative topic regarding the questions. There is a chat available in your screen. So please write all your questions into the chat. The presentation will take approximately 30 minutes, and then we will have enough time to answer your questions and deep dive into your inputs. As I mentioned, the topic is flexible manufacturing, specifically for the parts production. I mean, we heard flexibility and scalability already a couple of times during the executive session. So let me begin, with this overview, because this shows actually why we are investing into the flexible manufacturing concepts, because we would like to help our customers to somehow be in line with the trends and with the challenges which they are facing. And if we summarize those challenges in these 7 points, I mean, point number 1, high flexibility, because there are more and more models, coming to the market. And I think we hear that from Jörg, recently, that there are more and more models on the market. And also, of course, these models, they have different powertrain. We have still this internal combustion engine, and more we see the dynamic, development in terms of hybrid electrical vehicles, full electrical vehicles, and last but not least, also the hydrogen is ramping up. Of course, point number 3, it's connected with the process reliability, because everybody is looking to increase the overall equipment efficiency, to have the lines available, to perform better, and so on. And then, of course, we have also our customers. We have also the people who demands basically shorter reaction. So that means they would like to get their products, much more faster than it used to be. Point number 5, this is the Industry 4.0 topic, so digitalization. Everybody would like to, let's say, use the data in the clever way. That means to get the visibility, to get the insights into the process, and to use some kind of standard application which are easy to understand, easy to implement. And on the other side, we have, of course, higher automation demand. Everybody would like to automate more, because, of course, we would like to reduce the cost. We would like to reduce the non-added value workers from the lines. That means, to save some time, to save some money. And last but not least, we have also the logistics. Logistics is one of the topic which is more and more important, because usually the logistics processes are very much complicated. And to be able to increase the flexibility, we have to automate these logistics processes. So basically, these 7 points are driving our investment, our development in terms of flexible manufacturing concept. But for the concept itself, we need to have some building blocks. And that's our strategy, to have a building blocks available and to use it as a Lego, let's say, Lego bricks to build the smart and flexible line. We spoke about our pyramid starting from the products, which you can see here on the left side, where we have our robots, of course, industrial, collaborative robots, paint robots. We have there the peripherals as the positioners. But then, of course, we have there some additional portfolio, like portfolio from B&R, our company, where we have a lot of IoT hardware, allowing us to collect the data to make, let's say, Industry 4.0 ready. And then we have there also intelligent transportation systems, which are great, especially for the battery assemblies, because they can transport very fast, the products, the parts from one point to another point, and we are able to synchronize this with our robots. And last but not least, there is the latest addition into our portfolio, company ASTI with the broad range of AMRs and AGVs. Combining and using these products, we are building modular scalable application cells. And we would like to have these scalable cells ready for different application. Of course, starting from some traditional processes as welding, we are able to supply you with the arc welding cell, laser welding, spot welding, but then also moving, towards the plastics. So we have cells, standard modular cells for the clipping, screwing, ultrasonic welding, flaming, and so on. But then, of course, also some new processes as the winding for the hydrogen tanks, cells for the parts handling, process quality, etc. And combining all these building blocks together, as I mentioned before, we are able to build and deliver smart and flexible lines. To show you the example, I would like to switch to some dynamic animation, not to share with you only the static slides. So let me share my screen, and I hope you can see it now. So this is basically the concept as we see for the flexible manufacturing. But this is just an example, because of course, it's always important to discuss with our customers specific projects, specific parts. There is no one fit to all. We have to always analyze, the parts, the process itself, and then together to come to the best possible solution. And of course, for us, it's important to always find the return of investment and the clear business case. There must be value for you. So what I will share with you now, we will deep dive into the specific areas. This is just the example of the concept, but of course, let's say the key components are always the same. So let me start from the kitting zone. This is basically the area where we are integrating the logistics into the production line. So we are removing these yellow lines, basically creating these barriers between the logistic and the production itself. So in the kitting zone, in this particular example, of course, we are utilizing the building blocks. The building blocks here, which you can see, are the flex loaders. So these flex loaders are machines with the vision system. And with these machines, we are able to locate precisely the parts in the buffer, on the conveyors. And then we are able to load these parts to the carrier, to the AGV. As you can see in these first two machines, we are able to utilize the flex loaders in the way that we have even different parts in one conveyor, in one machine. That means this could bring you the flexibility, and this could also decrease the investment for you. What is important in the kitting zone, and this you can see in the example, we are always kitting one set of parts to one carrier. So there are all the parts needed for the production of one piece. Of course, in the kitting zone, you can see also the smaller machines for the smaller parts. And in the last section, you can see that we decided to integrate also some pre-assemblies. In this example, we have there two nut welding stations, so we can even do some pre-assemblies directly in the kitting, because this could bring, some more benefits in terms of cycle time, in terms of investment, etc. So this is the kitting zone. If we move back to the main picture, we could have also the so-called collaborative kitting, because we can utilize in the kitting zone also our collaborative robots. There could be a case that you have some small batches, or you have some special kits, special parts, and then maybe you need to collaborate really with the people. So that means we can use the kitting zone in the way that there are collaborative robots, which are safe for the close collaboration with the humans, with the people. And with this concept, we are able to bring also into this flexible manufacturing the collaborative kitting. So now we have all the parts loaded to the carrier, to the AGV, and we are moving to the production line itself. It doesn't matter if there is a welding line, like in this example, or there will be a line for the production of instrumental panel, more focusing on the plastic processes like a clipping, flaming, etc., because the concept is always the same. We have the cells with the options. And what I mean with the options is basically for this concept, mainly the option for the loading. In OP10, where you can see our modular application cell for the arc welding, you can see that we have a hybrid loading. So there is a handling robot loading the main parts into the fixtures, but then we have also the operator in front of the cell, because he is responsible to load maybe some complicated parts like small wires into the fixtures, which doesn't make sense really to automate. So as I mentioned before, we are not looking for, let's say, over-engineered solutions. We are looking for the solutions with a clear value for our customers and with the clear return of investment. If we compare it with OP30, where we have our modular application cell for the spot welding, there we don't have any operators. We fully automate the process, and we have only handling robot, so we don't need to keep the operator in front of the cell and load the parts into the fixtures. Last but not least, in this example, we have also process quality inspection. Again, the building block from our portfolio, where we are not only measuring the part, doing the geometry, checking the geometry of the part, but also we are able to check the quality of the process itself, like weld seam inspection, spattern, and so on. What is important, of course, and we mention it in the overview of the trends and the challenges, Industry 4.0. So what we are doing, we are enabling complete portfolio of ABB to be digitally enabled. That means to be ready for the data collection by default. So here you can see, how it works. We are collecting the data directly on site. That means into the edge environment. We are not pushing any data by default to the cloud, but we are not collecting only data from ABB robots, but it's important to collect data also from the process. That means from the PLC over the OPC UA, from the welding power source, etc. Because we have to combine and clean all these data together to really be able to provide the insights which can bring some additional value to our customers. So this is how we see the digitalization, to really have our portfolio so-called digitally enabled, to be able to collect the data by default about the process, and then to offer additional insights into the process. But of course, we would like to be also good, let's say, digital citizen. That means we are open and you can utilize collected data also in additional systems, in your, let's say, MES, ERP, and so on. It's only up to you to push the data outside, from the edge to the cloud, whatever. So it's always up to you. Coming back to the main screen, I would like to show you two more things. Of course, in this example, we didn't care about the footprint optimization because we would like to make it understandable. Of course, you can see here that the AGVs are running through different buffers, which is also very nice because then you can set up the buffers in the way as you need, you need to support your cycle time, your production, and so on. But of course, this concept can bring also the footprint reduction, because we are able to combine different safety zones in front of the cells, not having operators there. So here it's maybe a little bit more than it should be, but nevertheless we are able to really bring the benefit also in terms of footprint reduction. And last but not least, the scalability. This was the second main, let's say, topic discussed before: flexibility and the scalability. By having these modular application cells, which are always on the platform, so they are very easy to lift and shift, then in case that you need to get more capacity from your line, you can easily add different building blocks into the line and drive the AGVs, to those particular operations. We don't have anything bolted to the floor in between the cells. We don't have there any conveyors. It's only to change, let's say, the navigation of the AGVs from one point to another one. So This is showing basically our concept for the flexible manufacturing. In this particular case, specifically for the parts production, we are using our modular application cell portfolio as a building blocks, either in kitting, in the production line, and of course, we are combining that with AGV portfolio and AMR's portfolio from the ASTI company. Now I would like to move back to the slide, and I would like to deep dive a little bit into few more topics. So first of all, the ASTI. As I mentioned before, we are very happy to have ASTI in our portfolio because that was, let's say, the last missing piece in these building blocks. So now we have AMRs and AGVs in our portfolio, and as you can see, ASTI has really broad range of different AMRs and AGVs. Starting from the mouse or platform line, that means supplying the parts to the cells. Then they have a tractor line, forklift line, usually used for the warehouses or from the truck to warehouse and so on. And last but not least, also the boxed movers for different KLTs to supply different stations, etc. What I can recommend to you, there will be another breakout session starting 1:30 p.m. Eastern time, where we will deep dive into the ASTI portfolio, not only from the product point of view, but also software point of view, different navigations, charging. And I do believe it's very interesting. And if you have a time, please go there and listen, to our ASTI colleagues, because I do believe they have very, very interesting portfolio. One of the key components on top of the AGV is, of course, the carrier itself. I already explained to you that we are always, let's say, kitting one full set of parts which are needed to one-piece production. With that, we are able to follow really one-piece principle. We are able to ensure full traceability during the process. But then, of course, it's important how we are able to fix the parts on the carrier. We have developed basically two options for the fixing the parts. One consists of flexible pins, which you can see on the left side of the picture. And then we are able to use also the fixing, or positioning via gravity. What is important, we would like to bring also the flexibility here. That means the mechanism, it's designed in the way that we are able to change the fixtures on the carrier from one AGV to another one. That means you have really full flexibility in terms of producing more variants on the line. Because here you can see the main components of the carrier. So, of course, there is a docking station which secures, let's say, the positioning and also basically secures the communication between the carrier and the cell. Then there is a carrier itself and the main plate. On top of the main plate, we are using this fixing mechanism, consists of pin holders and the flexible rest. We have different design of the flexible rest, which allows us to really fix different parts precisely and safely on top of the carrier. What is important, we have also special gripper, which is for the configuration. That means you are able to put this gripper on top of the robot in the kitting zone, and you can reset up the carrier, the fixtures on the carrier in the way as you need for the next basically set to be kitted. Yeah, so again, we are trying to bring flexibility not in the production line only, but also in the kitting to really have real flexible manufacturing concept. The next thing is, of course, the software. Here we are utilizing our, let's say, software toolkit, which is called ABB Robot Studio, which support us during the complete life cycle of the project. We are able to start with some feasibility study, then to do really some kind of engineering simulations, and then, of course, this could support us with the installation, commissioning, virtual commissioning, etc. I would like to show you one video here, how the Robot Studio can help us in terms of simulations. Here you can see the simulation of the kitting zone. So we are able to validate in the virtual environment before we really start to build it physically, or to do some kind of, to fix the design, completely. We are able to simulate and validate basically different parts of the complete line. So in this case, you can see the kitting zone. And here we are simulating basically the loading to the carrier and also the cycle time, of course, because we have to fit the cycle time in the kitting to the production line itself. If we move one step forward, we are able now to use Robot Studio also for the virtual commissioning. That means we are able to validate and simulate everything inside of the virtual environment, inside of the Robot Studio, before we start to build the hardware physically. This is the reason why we decided basically to add few more functionality into the Robot Studio, mainly the communication via OPC UA. So that means we are able to link not only signals from our robots to the Robot Studio, but also we are able to link the signals from the PLC and additional equipment. And it doesn't matter if it's virtual PLC or the physical one. Of course, the benefit is obvious. First of all, we are able to move the project execution into this agile and virtualized world, which could bring the benefits like saving the time, like reducing the risks. But for me, the main benefit is that we are able to do the mistakes in the virtual environment, not in the physical one. And of course, there is a huge difference to do the mistake in the virtual environment if you compare it with the physical environment. Here again, I would like to show you one video, one example, how it looks like. So in this particular example, we have a setup with the Siemens PLC. So here we have a cell, which is completely simulated in the Robot Studio. That means complete mimic is simulated, including the fixtures, clamps, etc. Here we see the virtual HMI. Here we have a physical HMI. We are using the SIMIT for the communication between the PLC and the Robot Studio. And as I mentioned, we are able to validate and simulate all the signals, basically complete behavior of the cell. We are able to test all the handshake between the signals. We are able to validate the functionality of the programs and so on. If we go one step further, and with additional feature, which is by default inside of the Robot Studio, it's a virtual reality. We are able even to use that system, that setup, for some kind of training of the operators in, let's say, virtual environment, which is completely harmless. So this is additional feature which can be utilized, having this setup, having complete simulation of the production cells and production lines inside of the virtual environment. Okay, coming back to the slides, I would like to conclude with this overview. Why we believe, ABB solutions could drive this flexible manufacturing moving forward. On the left side, you see that we have really complex or complete portfolio for the flexible manufacturing. Of course, we have industrial robots, we have collaborative robotics. I mentioned BNR with the intelligent transportation systems, and last but not least, also the ASTI. Then we have a software and the service, Robot Studio supporting us for the simulations, virtual commissioning, digital twin, etc. But also we have global service coverage. So in case that you have our products inside of your factories, we are able to service that globally. And last but not least, Sami mentioned this at the beginning, we have close to 50 years experience with the automation and robotization. So we have really strong domain expertise, we have deep application know-how, and this is available globally with the local focus. So I really do believe that ABB is right partner for the flexible manufacturing, and we are ready and looking forward to get you in the contact and have a further discussion about your plans, how you see the future manufacturing, and especially this flexible one. Okay, so that's all from my side. And I can see the first question from Gabi. Do you have any existing installation running? First of all, I would like to mention that we have installation of the flexible concept in our technology center in Friedberg, which is close to Frankfurt in Germany. You can look also for some videos on the YouTube. If you type into the YouTube ABB flexible manufacturing, then you will get some videos from Friedberg, how it looks like. But of course, you are always welcome to visit us in Friedberg, and you can see it, the kitting, you can see the kitting there, the carrying, everything, it's implemented. But then, of course, we have also some real installations. One of the example, it's the installation for Volkswagen, where we actually installed this concept, not exactly what you saw before, because this is for the parts production. Of course, we have also the concept automating and bringing this flexibility into the, let's say, traditional body in white lines. Any additional questions? Meantime, I would like to mention one more thing to show you this QR code. We would be very happy if you can scan the QR code and fill in for us the feedback form. So that would be perfect. Thank you for it in advance. Any additional questions? As I mentioned, feel free to contact us, to contact your local, let's say, guys. Yeah, there is a question from Richard. Will this recording be available? Yes, the recording will be available on the website within next 24 hours. So then you can use it, you can play it again, or to share with your colleagues if they are interested as well into this flexible manufacturing concepts. Any further questions? If not, I would like to highlight that there are still few more breakout sessions in the agenda. They will start in 30 minutes exactly. Especially, I would recommend this ASTI breakout session to get more details about AGV and AMR's portfolio. Nevertheless, in case you have any kind of question for us, then please reach out to your local representative of ABB, and we will be happy to discuss with you flexible manufacturing and how we can basically jointly do something for you. Okay, thank you very much and have a great rest of the day.